Whenever you think of game development, most of you probably think of all the fun design you get to do, all the mechanics, the gameplay, the story, the beautiful art style, and so on. And obviously, every game has all these things, and they are really fun to work on, even though it requires a ton of work. But one thing that many players and newly found game developers might not realize is that eventually you have to optimize your game. So in this video, I will go over the very basics of a few optimization problems that we encounter in our game What Comes Next, and how we will also solve those problems that we have. But before we start, remember to wishlist the game on Steam. Now, before we start, I'm gonna explain this in very simple terms because there are already a million videos out there that thoroughly explains how each of these things work down to the bone. And I don't see a reason why someone with less understanding of it should try to explain it any better than them. So, anyway, when video game renders objects in games, it needs to understand what to actually render and how to compute that. And this is being done by calculating triangles. For example, if we have a box in a game, it has 6 sides, and each side is basically a square. That square is then divided into 2 triangles, so in order for the game to calculate this object and render it, it has to render 12 triangles. The more triangles a game has to calculate and render, the worse the performance will be. So if a game has, for example, 20 million triangles in your current view, that will tank your FPS quite a bit. And then you have to take into fact that there are scripts, shaders, which is basically calculations on how to render things differently, animations, lighting, shadows, VFX, etc, etc. So you can imagine how problematic this becomes unless you use 3D models that are optimized to begin with. And this is a big reason why some games decide to go with a low poly art style, because low poly basically means a low amount of triangles on your models. Another thing I quickly want to mention is how lighting works in games as well, and how that can influence your performance quite heavily. In order for games to look realistic and have beautiful looking scenes, you need good lighting and shadows in order to create contrast and more visually interesting scenes. But a problem with this is that rendering shadows is quite performance heavy as well. First, the game needs to render and project a light, which will alter the way that textures and models look and behave. And secondly, it will also create a shadow that once again will be projected and alter the way that textures and models look and behave. And when we talk about lighting, we have 2 different forms. We have real-time lights, which is basically a dynamic form of lighting, just like how the real world works. If I'm standing in the sun, I will get hit by the light and I will create a shadow. Now, if I walk away a little bit and then turn around, the light will hit my back instead, and my shadow will be projected in another place. Or games can also use baked lighting, which is basically you pre-render the lights and the shadows and they will always be in the same place no matter what. These objects will not move, and therefore the shadows won't move either. There are sometimes problems that occur with baked lighting because it requires a lot of settings to work properly, and as you can see here, it can just look quite bad if you don't do it properly. And also, in our experience by doing this in Unity, is that it just never works. And obviously, there is a problem if you only have baked lights, because that means that you will never have moving shadows, which can be quite boring and not very visually interesting in games. And that is probably something that most of you have noticed sometimes when playing, like, why is your character's model not casting a shadow? Well, it's because the game developers either couldn't optimize it, they couldn't make it work, or they were just lazy and decided just not to have it at all. But what about games that bake lights and also have moving shadows when objects are animated and can move? Well, you can have multiple light sources in game engines, and you can set some of these to baked and some of these to real time, which when mixed good can create a great looking game that is also well optimized. Did you know we have a public Discord where you can see more behind the scenes footage, get to know the team, hang out with the community? And you can also share any work that you've done or anything that you're currently working on, because we love seeing what others are up to as well. So if you haven't done it already, join our Discord and become a Dandelion today. Another thing that you learn as you develop games is that there's just an infinite amount of problems that can occur, and you just have to learn to get past them somehow. even though sometimes you have no idea what the problem is, how it occurred, and how you're going to deal with it. Recently, we redid our environmental art in the first level, and it is really starting to look incredible. But we noticed that our FPS started tanking, and it wasn't really because of the most obvious reasons such as lights or triangles. No, this was something else. And we started investigating, and we started noticing that the way we did all our trees and our foliage in our game was probably one of the biggest reasons why we had this problem. You see, this was one of the first times some of our 3D artists made trees, so we just checked on YouTube how to make beautiful stylized trees, and we found a bunch of videos all showing the same thing. You make the trunk of the tree, some branches, etc., and then you create a bunch of planes that intersect with each other. Then you take an image of leaves and put this on all the planes. But by only doing that, the tree is gonna look awful. So there's one last thing that is required for this to work. Well, you put all these planes as transparent. So only the leaves are visible when you look at it. And then you get this gorgeous looking tree that has a ton of leaves on it. And that's where the problem comes in. Transparency. And since we just found this problem, I will do my best to explain this in an easy, simple way. And I hope that this is the correct way as well, because this is my understanding of how this works at least. What happens is that the camera in the game renders everything it sees, right? And it does this basically in steps, because it cannot calculate everything at once. So if you have a plane, and then you put a texture on that plane, and then you decide to make certain parts of this texture transparent, the game has to render the texture, then decide what should be transparent and what shouldn't. But what if you have two images stacked on each other? Because our trees have like hundreds of these planes all over the place. Well, the game has to render the first texture, then decide what should be transparent, and then it has to do it again with the image behind it. But this time it has to take into consideration how much of the view the first image is blocking. And then it has to run all these calculations again. So what happens then if you have 20 images stacked on each other in 5 different places in a tree? And not only that, but you also have hundreds of trees in your view. So it has to do all these things times 100. And that, folks, is why we have some performance issues in our game currently. So the obvious thing that we need to do is we need to rethink how we make our trees. And obviously we have to redo all of our trees in our game. Now there are instances where you can use this technique that we used in order to make trees, and they can be visually really good looking. But for our game and for our scene, that contains a very high amount of trees and bushes and flowers which are made in a very similar way. We just have to redo it completely. Another problem that we found was we had a method of making our grass textures look better by using a camera that renders our terrain in order to generate a terrain texture so we can enhance our grass through shaders. Which in hindsight is both a bad and a good way of doing this, because the camera actually just rendered the entire terrain and everything on it all the time. So we did a temporary workaround for that. So when the game starts, the camera is active for a split second in order to generate a terrain texture that we can then use in our grass shader to make our grass look better. But after that split second has passed, we deactivate the camera instead so it doesn't render everything at all times. Another problem that we also had is that our current shaders does not support batching or GPU instancing, which I won't go into detail right now what that is, but it helps performance quite a bit. And the same thing with our LODs that were quite poorly made as well. And lastly, we're still working on a way to properly bake lights into our game, because Unity just decides to legit always trolls you no matter what and never let you bake lights properly. So Lord help us on that one. And that, my dear friends, is how we will optimize our game. Thank you very much for watching the video. Remember to wishlist the game, join the Discord, follow us on all our social medias, and I'll see you in my next stream or in the next devlog.